Welcome to the Explainer. So, if you've spent any time building with generative models, you already know the honeymoon phase is definitively over. Getting an AI to just output text is easy, but getting it to actually survive contact with the real world without leaking data or making completely foolish strategic decisions, well, that's the real nightmare, isn't it? Today, we are moving past those fragile toy-like setups and diving into hardened, enterprise-ready architectures. We're going to explore exactly how to upgrade an AI system by fundamentally fixing its brain for deep, strategic reasoning, and then forging an absolute unbreakable shield for secure data retrieval. Let's get into it. Okay, let's dive into this. Here is our roadmap for today. First up, the naive AI problem. Second, game theory prompting. Third, advanced strategic reasoning. Fourth, the zero-trust RAG paradigm. And finally, number 5, securing the retrieval pipeline. Basically, we will first rewire how the AI thinks logically before moving on to secure its external data pipeline. So, starting off with Section 1, the naive AI problem, and exactly why those defaults out-of-the-box implementations completely fail when faced with real-world complexities. Let me ask you kind of a dangerous question. Are you treating your AI's environment as passive and its retrieved data as safe? Because if you are, look, you're not alone. That is literally the default developer mindset right now. We just sort of tell it what to do and give it documents to read, right? We assume the systems we are building operate in this friendly little vacuum where users always behave themselves and data is perfectly clean. But let me tell you, in a production environment, assuming your AI operates in a friendly vacuum is an absolute recipe for disaster. Now, what's really interesting about this contrast is it's just night and day. The naive AI, it's basically a golden retriever. It has a single agent focus, meaning it only thinks about its own immediate action. It optimizes exactly one step ahead, it's super eager to please, and worst of all, it inherently trusts whatever context you hand it. But the hardened AI, that one plays chess. This system takes a rigorous multi-agent perspective. It's constantly modeling out competitors, bad actors, and shifting variables. It seeks equilibrium, meaning it looks for a stable long-term outcome, not just a quick fix. And crucially, it trusts absolutely nothing without validation. It filters everything. We are talking about moving from a vulnerable, overly trusting system to a rigorously machine-enforced architecture. Which brings us perfectly to Section 2, game theory prompting. This is where we initiate the first major upgrade, the AI's brain. We're changing the fundamental way we prompt the AI to reason about problems. Let's really define this paradigm shift. A game theory prompting framework is a method where instead of just asking the AI, hey, what should happen, which, let's be honest, usually gives you generic fluff, you actually force it to identify the game. You explicitly command it to analyze the players, the incentives, the strategies, the payoffs, and any information asymmetries. Why does this matter so much? Well, because standard prompting lets the AI take the lazy route. By forcing it to map out these specific game-theoretic elements, you yank it right out of simple reactive mode. It forces a massively deeper, richer, and just way more realistic analysis. Think about how you'd normally prompt an AI. You might say something like, analyze this product strategy, and the AI gives you a polite, generic list of pros and cons that's completely disconnected from market reality, right? Now shift to a game-theoretic prompt. You say, model this as a multiplayer game, identify incentives, and find the equilibrium. Suddenly, the AI can't treat the environment as passive anymore. So the crucial point is that this specific phrasing forces the model away from simple summaries and pushes it into rigorous strategic realism. It literally has to think about how competitors will react, what the countermoves are, and where the market will ultimately settle. Moving right along to Section 3. Advanced strategic reasoning. Let's take this theoretical multi-agent perspective and look at the specific frameworks and tactics you can implement right now. So what does this actually look like in practice? Well, we've got an incredible arsenal of tools here. First up, adversarial prompting. This is where you turn queries into a game-theoretic red team exercise, which is absolutely perfect for stress testing, cybersecurity, and fraud prevention models. Then there's self-play prompting. Instead of asking for just one perspective, you literally pit the model against itself. By forcing it to debate its own outputs, you forge a much stronger, battle-tested solution than a single iteration could ever give you. For broader strategies, we use coalition analysis. This mirrors cooperative game theory, which is brilliant for navigating complex business partnerships or tricky organizational politics. And finally, incomplete information prompting. In the real world, you never have all the facts, right? Phrasing prompts to mirror Bayesian game analysis helps the model navigate uncertainty and calculate probabilities without just freezing up. Now, when you're building agentic systems, meaning AI that actually takes autonomous action, you absolutely must use explicit incentive modeling. By making the AI think critically about incentives, you catch reward hacking and coordination failures way before you ever implement the system. But honestly, the most fascinating part of all this is recursive strategic reasoning. Humans normally operate at level 1, I think. But game theory requires recursive depth. It asks the system to compute, I think that I think. By prompting your AI to reason recursively like that, you unlock this massive potential for handling complex diplomacy, intense negotiations, and navigating highly competitive, totally unpredictable markets. All right, we've upgraded the brain. Now for Section 4, the Zero Trust RAG paradigm. We are transitioning from internal reasoning to forging the shield, how the AI safely accesses external information. Let's define Zero Trust RAG. This is a total paradigm shift for anyone building with large language models right now. It means treating your retrieval pipeline as a hard security boundary, not just a glorified search system. Every single retrieval step is explicitly authorized, validated, and filtered by machine-enforceable policy as code before the LLM ever even sees it. We're shifting from a sloppy retrieve and generate setup to highly controlled ADA access. Think of hardcore policy engines like Open Policy Agent or AWS Cedar, acting as the uncompromising bouncers to your system. Zero, that is exactly the amount of trust you should place in retrieved context. Treat everything as hostile until proven safe. Why? Well, because text can easily be manipulated by outside users. Embeddings can conceal malicious payloads specifically designed to compromise your model. And metadata, the tags telling your system what a file is, can be spoofed so easily to bypass basic filters. Honestly, even internal enterprise systems can be compromised. The rule of thumb is simple. Verify, trust temporarily for a single operation, and then re-verify downstream. And this brilliantly illustrates why traditional REG systems fail constantly in the real world. First off, they treat the vector database as trusted storage, which is just a massive architectural flaw. Second, they completely skip policy enforcement at retrieval time. Third, they routinely ignore strict multi-tenant isolation boundaries. And finally, they rely on weak prompt instructions for safety, basically telling the AI, hey, please don't read these restricted documents. Look, relying on prompt instructions is like asking a hacker politely not to hack you. You absolutely cannot protect a production system just by asking the LLM nicely to behave. So, how do we actually fix this? That brings us to Section 5, securing the retrieval pipeline. Let's introduce the concrete architecture required to move enforcement completely out of the LLM and directly into the pipeline itself. Let's move to the architecture and see how this builds an absolute gauntlet for any piece of data flowing through your system. Step 1 is query time classification, immediately identifying the intent of the user's request. Step 2 is retrieval. Step 3 is the critical choke point, validate and authorize at the policy enforcement point. This determines whether to allow, deny, or redact info on a strict per-document basis. Step 4 is transform and sanitize the allowed data. And finally, Step 5, trust-aware re-ranking, where anything remotely suspicious gets shoved right to the bottom. A document only earns the right to be passed to the LLM if it survives this exact rigorous defense. Zooming in on that context sanitization layer for a second, think about a raw document. It's a potential minefield of unmasked emails, exposed internal IDs, and maybe even a nasty prompt injection attack hiding inside, commanding the AI to ignore previous instructions. Feed that straight to an LLM and boom, your system is compromised. But a sanitized document, it tokenizes all that personally identifiable information, hashing names and emails. It strips out known prompt injection patterns, and most importantly, it securely wraps the text in explicit data tags. This strict separation ensures the LLM reads the text as passive data, absolutely not as an executable command. Then, right before we hand anything over to the model, we hit the final gates, LLM orchestration and auditability. See, Zero Trust RAG doesn't just give raw freedom to the model. We use tool-first enforcement. If a query asks for the latest financial data, we force a rigid API call to a specific finance tool, instead of letting the RAG system just guess. We also enforce context budget control, strictly limiting the max tokens and max sources per tenant. The LLM is never allowed to decide what gets included. And finally, the auditability layer logs every single decision. This is completely non-negotiable for debugging, adversarial analysis, and maintaining essential enterprise compliance like GDPR or SOC 2. I want to leave you with this final provocative thought. Take a hard look at your own systems right now. Is your AI a strategic architect capable of recursive reasoning and shielded by an ironclad zero-trust pipeline? Or is it just blindly trusting its next token and whatever raw document you throw at it? Upgrading from a naive implementation to a hardened AI requires fundamentally shifting both how we prompt and how we protect. Thank you so much for learning with me today in this explainer. I really hope this empowers you to build smarter, safer, and much more resilient systems.